Yeah, continuing from where we stopped, we are going to look at the consumer. We are going to look at the consumer and the producer's surplus statement. Now, normally when we have got these two statements, we actually look at the deviation that exists between two parties that are actually doing business, and then we can be able to determine the values of the activity that normally happens at the process. So for example, let's say we've got, suppose the demand curve of a function p is equal to fq, and is equal to 50 minus 0.1 q, and again supply curve p is equal to supply curve p is equal to gq, which is 2q plus 20. Okay, then we can say find the equilibrium price, and the compute the consumer and the producer surplus. So this is actually the question that we can have. So normally we have got some key points that are noted. This is actually the point of equilibrium. So you can actually see that we have got an equilibrium point, and so if I want to get the equilibrium price, it means that I should be able to make a comparison to say this one 50 minus 0.1 q then is equal to 0.2 q plus 20. So once we have this, it means that we can actually get the equilibrium price. So normally in solving this one, I can take this, bring it to the other side, so it will be 2q plus 0.1 q, and I can take this other one, it will be 50 minus 20, so this is going to be equal to 30 and 0.3 q. So q in that case is equal to 30 divided by 0.3, which gives us the value of 100. So it means that we cannot produce more than 100. That's the maximum threshold that we can have. So if we can be able to actually now substitute this 100 into P star, then we can actually say it will be 0.2 multiplied by 100 and then plus 20. So this gives us the value of 40. And having done that, then we have got the 40. So P star in this case is actually the maximum. So if I want to get now the consumer surplus, then it is going to be equal to 0 to maximum of production, which is 100. Then I will say 50 minus 0.1 q, and then I will take minus 40, because this particular 40 is the one which can be obtained here. So you just take this 40 and jump the bridge, and this is the equation, and then you multiply this one by dq. So integrating this one, you can now substitute like the way we have. You can have a value of 500 as the value, okay, as the value. Let's take a guy up. Yeah, it can be a value of 100. So after having done that, 500. Having done that, you can now look at the producer surplus. So it's now the opposite. So like in the first place, you actually you take an integral of 100, and then we have got 0. Then you actually now take 100 and put it here, so that you should find how much is this particular value. So if you take 100, so it will be 50 minus 0.1 times 100, which is equal to 50 minus 10. So the minus it will be 50 minus 10, which is equal to minus 10, which is equal to 40. So when you do that, then it will be 40 minus the one which is coming that side, 0.2q plus 20, and then it will be dq. So it will be like this. So at the end of the day, if you can be able now to simplify, it will be 100, 0, and then this is going to be equal to 20 minus 0.2q. So this one divided times here times dq, which normally gives us a value of 1000 if you solve. So in that case, we can actually now say what will be now the surplus in that. What will be now the surplus in that? So the surplus is the difference, which is equal to 500 minus from 1000. So it means that these people were able to make 500 as an extra amount that could be made from that particular point. So that's the most important part, which normally defines this particular statement as the producer and the consumer surplus. So having done that, I'll give you as many exercises as possible so that you can be able to make practice as to what defines what in that context, so that you should be able to know how things can go. Now, on the other part, remember, we in secondary school, I mean at a undergraduate level, we normally do sometimes like partial mathematics. Let's assume I've got a function fx multiplied by gx, okay, multiplied by gx. Now, according to the rule, if these are multiplying each other, it means that I can be able to take fx prime multiplied by gx, and then I can say fx multiplied by gx prime. So this is what we know. So having done that, we can now be able to say, what if these ones are integral? What if these ones are integral? If these ones are integral, then we can be able to actually put some integration here and there, so that we can now put here dx and there dx. Now, so this is actually the integration that we have. So at the end of the day, we can now be able to say, what about this one? So we can actually make this one as the subject of the formula. So it can be f prime x multiplied by gx dx, then is equal to, so you can actually see that I can take this one, it must go the other side. So it will be fx gx minus integral of fx and gx prime dx. It will be like that. So this equation, it defines what is called integration by parts. It defines what is called an integration by parts. Okay, and in the next section, I'll give you more examples of integration by parts, so that we should be able to understand them in that context. So I will continue in the next section. Now, this time around, looking at how we can apply some of these